All right, so this is just a quick video of me explaining non-permissible values, which is the first thing we are going to look at for rational expressions. Now I have two screens going, so you might notice that I am looking this way for most of the video, but it is because that's where the screen that I am writing on is. So don't think I'm too crazy. So you'll notice on these notes that the first thing just kind of talks about what you'll be able to do by the end of this section. So you can kind of take some time to look through those. Maybe when we're done, 6.1, you will be able to hopefully check off all of these boxes. So you can read those on your own. You don't need me to read to you. So just starting here on the page, rational numbers. And just so you know, these notes are going to be posted for you. So you can choose to print these notes before this video so that you can kind of follow along as I'm going, or you could even copy them out on loose leaf so that you can follow along as I'm going, but that'll be your choice. You can also just copy as I explain to, pause the video whenever you need to, etc. So rational numbers, as you know, is any number that can be written in the form of m over n, aka any number that can be written as a fraction is a rational number, where n cannot be zero. And if we were in class, I'd ask you, why can't n be zero? But I'm by myself, so I'll just tell you. N can't be zero because you cannot divide by zero. It's impossible. So it's called undefined usually. So in this case, we call it a non-permissible value. So rational expressions are any algebraic fraction with both the numerator and denominator that are polynomials. And if you remember, polynomials is basically, it's a very broad definition, but it's anything that's like variables and coefficients. And just keep in mind with those variables, the exponent has to be a positive number. But yeah, that's basically what a polynomial is. So some examples, they have 1 over x, m over m plus 1, y squared minus 1 over y squared plus 2y plus 1. And then, as I said, non-permissible values, anything that will make the denominator 0. Okay, because if the denominator is 0, we know that's no longer rational. So it makes it a non-permissible value, a value that doesn't work. So the first example, 1 over x, the non-permissible value for x is 0. Because obviously, if you plug in 0 for x, in this case, the denominator would be 0. So the non-permissible value for x is 0. So what about the next example, m over m plus 1? What is the non-permissible value for m? So what, if I plugged it in for m, would make that entire denominator 0? Now, most of you probably know the answer just doing that math, right? If m is negative 1 plus 1 would equal 0. So negative 1 is my non-permissible value. But they won't always be this easy. So I just want to quickly explain kind of what your method is. So essentially, you take the denominator, you make it equal to 0, and then you solve for m. So we bring m to the other side. So m is equal to negative 1. So whenever m is negative 1, I have a non-permissible value. So we would typically write m cannot equal negative 1. And if there was multiple non-permissible values, then we would just list them. So you'll see that down here. So I'm going to go through all of these examples down here. So again, if you're just copying notes as we go, you could pause the video at this time to copy down all of these examples, and then I'm going to go through them with you. So determine the non-permissible values for the expressions. So for 4sr squared. Now, everything is attached in this example. So most of you can probably figure this out in your head. S cannot be 0 because if S is 0, everything is going to be times by S. And that would mean anything times 0 is 0, right? So if S is 0, then the entire denominator would be 0. So that means that S cannot equal 0. Same thing for R. If we did 0 squared, it would be 0. That means that everything would be times by it, which would make the entire denominator 0, which is what we don't want. So R cannot be 0 either. Now, again, it's important to know kind of how you solve this. So just really quickly on the side here, typically what you would do is you would just take that entire expression in this case, make it equal to 0, and then you take turns solving because there are two different variables there. So if I solve for S first, I would divide by 4r squared. So I divide by the other things attached to it. 0 divided by anything is 0. So it would mean S, because the 4 cancels out and the r cancels out. So S equals 0. So S can't be 0. Same thing if I wanted to solve for r. So I'm just going to erase this. If I was solving for r instead, I would divide by 4s because that's what's attached to the r squared. So divide by 4s, and then I get r squared equals 0. And then in order to get r squared alone, I would have to square root. Square root of r squared is just r, and square root of 0 is 0. So r cannot be 0. So again, some of these you'll be able to do in your head, so you don't have to show all this work. Others you'll just have to show some work, and I just kind of wanted to show it just so that you know. If ever you're questioning your answers for any of them, you need to solve it algebraically, right? You're not going to magically figure it out. So if you're questioning yourself, it's important to know how to solve algebraically. Right, so for the next one, for example B here, you'll see that there's two things. So there's an X out in front. So however many brackets or things there are as the denominator, you just make each one equal to 0. So X equals 0, 2X minus 3 equals 0, and then you just solve for X for each. Now in this case, X equals 0, that's already solved for us, great, so X can't be 0. This one I'll need to do some solving. So I bring that 3 to the other side, so I add 3 to both sides. I get 2x equals 3. I need to divide by 2 to get x alone. So x equals 2/3. Sorry, x equals 3 over 2, not 2/3. Sorry, getting ahead of myself and wasn't really watching what I was doing. So x equals 3 over 2. And then basically for your non-permissible values, you could write x cannot equal, and then you just make sure you include both. So x can't be 0 or 3 over 2. And that's that. Next one, we only are interested in the bottom. So it doesn't matter if it's y squared minus 1, you don't really need to look at it. Non-permissible values only come from the denominator. So y squared plus 2y plus 1. What you have to do is see if that bottom can be factored. And it can. It's a perfect square trinomial. So that will factor to y plus 1 squared. And then that y plus 1 squared is what I am going to make equal to 0. And then solve. So in this case, I need to take the square root right away so I can get rid of that squared. And then that leaves me with y plus 1. Square root of 0 is 0. Bring the y or the 1, sorry, to the other side, and you get y equals -1, which means that y can't equal -1. So we just write it like that. Factor this one. So p squared minus p minus 12, that factors to p minus 4 and p plus 3. Again, you make each equal to 0 and solve. So p cannot equal 4 and p cannot equal -3. And again, as far as non-permissible values are concerned, you could circle these, or you could just write p cannot equal -3, 4. Do you have to write them in numerical order? No, just list them. Numerical order obviously is great because it's just the easiest way to read it, but you can write them in whatever order you want. So this next one down here, 3bc, works very similar to the 4sr squared that we already did. So I'm not going to waste time explaining how to do that. Go back to earlier in the video for the 4sr squared if you want. But basically, you would solve for each individual. You would take turns solving for the different variables. So you could solve for b first, then solve for c, or you can just recognize that if either one is 0, the whole thing would be 0, so both cannot be 0. So b cannot be 0 and c cannot be 0. And obviously, you don't have to do anything with 3 because it's just 3. So same principle here, x plus 2, x minus 3. You would use the same that I did here. So I'm not going to waste time explaining that either. X plus 2 equals 0, solve for x. X minus 3 equals 0, solve for x. Again, you could go back into the video when after I factored, made each thing equal to 0 and solved if you really need to, but each thing equal to 0, solve for x. So x cannot be -2 or 3. And last but not least, m squared minus 4, you would factor. So that's m plus 2, sorry, I'm getting ahead of myself again, and m minus 2. That is a difference of squares. So again, you would make each thing equal to 0 and solve. And then typically, because this one will be plus 2 and minus 2 as our answers, we can actually write this. It's a symbol called plus or minus. So you draw a plus sign with a minus sign underneath of it, and then you write 2. So it means m cannot equal plus or minus 2. And that's it. That's your non-permissible value. So it's just anything that make that denominator 0. So you take whatever the denominator is, you make it equal to 0, and you solve. And in most cases, you will have to factor first. So you'll take that denominator, factor it, and make any brackets that you have equal to 0 and solve for all variables. And that's it. That's all. So in this, wherever I decide to post this, I think I'll do it as an assignment, but wherever I decide to post this, there will be attachments, and those 2 attachments are your homework. Okay, so make sure you copy these notes and get that homework done before you come back to class next. Thanks.